What's going on, everybody? Hopefully you can't hear that machine humming in the background. I have no idea what it is, but it just started right as I was about to hit record. But we are going to be doing the example problems for the Chapter 4 physics notes over circular motion. We've got two examples. We have an ant who is sitting on a record player as the record is spinning, and then we have an object sitting on a circular path, and we want to know what the radius of the circle is. Here we want to know what the velocity is. Both of these, I don't think you guys are probably going to be able to hear it on mic, but it is very distracting. But both of these are going to use the same formula. We have I'm going to use circular just to differentiate. Our velocity for circular motion is equal to 2 pi r over capital T. And capital T is equal to the period, which is seconds over rotations. Seconds per rotation. Okay, for our first one, if we set up our V equation, V equals 2 pi r over t. We have diameter, which is technically the same as 2r. So when we plug that in, we'll just get 0.305 meters times pi. So there's our top part. But then for the bottom, we have to do a little bit more to get that one. It gives us rotations per minute. So first thing we're going to want to do, that's 45 rotations per minute. We can convert that into, there are 1 minute or 60 seconds in 1 minute. That will allow us to convert into rotations per second, which will give us 45 divided by 60. 0.75, we'll go ahead and call that RPS. And then if we want to go from T or F to T equals 1 over F. And what this basically means is that if it takes 0.75 or one rotation happens, let's get to the beginning of here. There are 0.75 rotations every second. That means the inverse of that, 1 over 0.75, is how many seconds it takes for a complete rotation to happen. So we'll go ahead and do 1 over 0.75, and we will get 1.333 repeating, or 1 1/3 if you're feeling like using fractions. So that is the number that's going to go right here, 1.333 repeating, and that is seconds per rotations. Now notice when we multiply this by pi, this will give us a meters per rotations, and our rotations will cancel and we'll be left with a meters per second. Now that's not really what's happening, but I think it's the easiest way to understand why our units need to be set up the way they are to get them to work out. So we'll go ahead and hit equals, and I'm going to go ahead and I'm going to maintain that value right there. And we're going to, man, my finger has been hurting a lot lately. Just randomly get joint pain. I hope it's not the arthritis and the old age coming to get me already. 0.305, and then I'm going to use the pi button again. Don't use 3.14, please. You have a button for it. And then we're going to do divided by answer, which should have been the 1.3333333 repeating, and you will get 0.7186393195. You should expect to get a big number because of the whole pi thing. But if we round that, the 0.7186 blah, 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 we can round that to 0.719 meters per second. So under 1 meter per second, not too shabby, not that bad. And let me just make sure I got that's the answer I got. Bam, bam. 0.305. Make sure that looks correct to me, I think. Yeah, looks correct to me. It's not the answer I had before, but I trust my work now because I think I did the work in my head earlier. I'll have to investigate after this. So if this is wrong, well, I guess you won't see this video because I'll have figured out it's wrong and I will have re-recorded it. Anyway, though, we can go to the next example. We know that an object is currently moving at 25 meters per second as it's going around, the circle. And it's 10 rotations every 25 seconds. We want to know what is the radius. So we're going to use the same. V equals 2 pi r over t. We can rearrange that to solve r equals vt over 2 pi to get r by itself. And then we have enough information for pretty much all of it. We can plug it in. The trick here, though, is that we have 25.0 meters per second. We don't have t, which again is the time period. It's in seconds per rotations. But instead of like solving for rotations per second with this, we can literally just set it up as it is the seconds per rotations. And then on the bottom, we'll just get our 2 pi plugged in there. And if we plug that in, you will get to 25 divided by 10, which gives us 0.25, times 25. Oh, the machine noise is back. I, again, hope you can't hear it, but it's very distracting. And then divided by 2 pi equals, we get a diameter, or a radius, because it asks how far away. In the original question, it asks how far away from the middle is it. So that's a radius. That's what it's asking for. We will get multiple equal signs there. 9.94718 blah, 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 which we can round to 9.95 meters. It's a little under 10 meters away from the center of that circle. All right, that'll be it for this example problem. They're pretty straightforward. I hope you didn't have any struggles or anything with them, but they're good to make sure we get them out of the way. In the meantime, though, if you have any questions, shoot me an email. Otherwise, this is Mr. Diamond signing off. Have a good rest of your day, everybody.